Hi everyone, today in Integrated Math 1, we're going to go over Chapter 12, Lesson 5. Here are the objectives. Make sure you write them down in your notes. Alright, we're going to go over postulate 12.3, which is angle side angle congruence, which is also known as ASA congruence. If two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. So, first thing we want to see is if angle A is congruent to angle B. Angle A, so 1, 2, and angle D, 1, 2, they're showing those two are congruent. And then we know that side AB is congruent to side DE, which is shown here. Those two are congruent. And angle B is congruent to angle E, which is shown here. Then we know that these two triangles are congruent by angle, side, angle. Angle, side, angle. Angle, side, angle. So we have triangle ABC, which is congruent to triangle DEF. Well, let's check this out. A is congruent to D, which is what we showed here. Check. Side AB is congruent to side DE. The first two. Check. And then we have angle B is congruent to angle E. B is congruent to E. Check. And it's shown here as well. So we know this is a true congruent statement. And notice here we also have angle, side, angle. And it's not angle, angle, and a side over here. It's angle, side, angle. Then we have theorem 12.5, which is angle, angle, side congruence, also known as AAS congruence. If two angles in the non-included side of one triangle are congruent to the corresponding two angles and side of a second triangle, then the two triangles are congruent. So here we have angle, and we're talking about angle A, and then we're talking about angle D. They both have two arcs. So that's good. Then we're talking about our other angle, which is next to it. Notice that. We have angle B and angle E. That's good. Then we have the side BC, which is congruent to the other side EF, which is congruent here. So now we can make our congruent statement for each triangle. Triangle ABC is congruent to triangle DEF. So first of all, we're looking at A is congruent to D. First and the first term here. That's good. Then we know angle B should be congruent to angle E. B and E. That's good. BC, second, third, with EF. That's true here. So we do know that these two triangles are congruent. And we've proven that with angle, angle, side congruency. Alright, so here is just a quick little summary of all the different ways to prove the triangles are congruent that we've learned so far. Side, side, side. All sides of both triangles must be congruent. You can also prove it with side, angle, side, side, angle, side, side, angle, side. Then we have angle, side, angle, angle, side, angle. And last but not least, we have angle, angle, side, which is the same as angle, angle, side. If we have proven any one of these, we know that our triangles are congruent. Alright, so here we're going to be proving angle, side, angle. We have angle, we have our side, we have our angle here. So let's see if this is even possible. I'm going to extend these out. So now you can see that we have angle, side, angle. Angle, side, angle. So now we have seen that it is possible to prove this with any of these triangles. Alright, next we have angle, angle, side. Angle, angle, side. Angle, angle, side. So let's see if we can show this. Oops. Extend that out. Just a little bigger here. And as you can see here, we have angle, angle, side here. And we've proven that we can have congruent triangles with angle, angle, side. Alright, so now you can see we also have right triangle congruency. So we have the leg-leg congruence, which says if the legs of the right triangle are congruent to the corresponding legs of the other right triangle, then the triangles are congruent. This is also known as LL. So as you can see here, it also looks like side, angle, side. Side, angle, side. But the only difference here is that it's for a right triangle specifically. Then we have our other theorem, hypotenuse angle congruence. So here this also should look pretty familiar because it is angle, angle, side. Angle, angle, side. And the leg angle congruence, you have an angle, side, angle. Angle, side, angle. And last but not least, we have the hypotenuse leg congruence. So if we're looking at the hypotenuse leg congruence, we have side, side, angle. We have S, S, A. So this one's an exception. Notice here on the proving triangles are congruent, there is no side, side, angle. That's because this one does not exist except for right triangles. Okay. This one, side, side, angle, is also known as a donkey theorem. The other way that you can also know it is no bad words in math. So this does not work unless you are proving that right triangles are congruent. So just keep that in mind. And that's it.